Welcome to my YouTube channel. I appreciate every one of you that have subscribed to this channel. I want to say a big thank you to you all. And please, I welcome your comments, observations, and questions. Don't just watch and benefit. Please share to your friends and to your classmates. For today, please get ready with your drawing instrument because I'll be showing you how to find or determine the resultant of two vectors by triangle method. If you are ready, let us go. Now suppose you are to find the resultant to these two vectors using triangle method and also by scale drawing. I'll start by selecting or choosing the scale, a suitable scale that will help me. Now this is a vector of magnitude 50 Newton, this is 30 Newton. If I decide to choose a scale of 1 cm on my drawing, what I'm going to draw now, let it be equal to a vector of 10 Newton. If my diagram is not going to be too small, if it's going to be too small, I can reduce it to 5 Newton. So that if I have a vector of 50 Newton, I'll need a line on my drawing of 5 centimeters. That is 50 over 10. And if I want to represent a vector of 30 Newton, I need a line of 3 centimeters. That is 30 over 10. So having done that, the next thing to do is to start somewhere, just the way this vector is, and decide to start from here. Or if I wish, I can even make this vector F1 horizontal. It mustn't always be in this direction. You know what you are doing. I will make it horizontal. Then in that case, if I make it horizontal, then I'll start. Let's say I start from this point. This is my point. Let's call this my point O. So this is my point O. I'll take a line of 5 cm. This is 0, 1, 2, 3, 4, 5. Line of 5 cm. Okay. So to represent my vector of 50 Newton. Then I'll now, with my protractor, I have to, if I extend this line, this is my protractor and this is my compass. So if I don't want to construct angle 60 or 120, I can place my protractor like this and measure at this point the end of vector F1. Make sure this line joins to this line, this horizontal aligns with the vector F1, and then you mark your 60 degrees starting from this end here. This is 0, 10, 20, 30, 40, 50, 60. This is my 60. So I'm going to join it to this. I can use a pencil first of all and draw a thin line, like a construction line. Then I have to mark my 3 cm because vector F2 we're going to act along this line, and it is 30 Newton, which is 3 centimeters. So I'll come here. I can use my protractor, or sorry, my compass to mark off that length. Or I just come here, measure 3 cm. This is my 0, 1, 2, 3. This is 3. Then I make this bold or thick. Okay, so this is my vector F2. Now this is 60 degrees and this will be 120 degrees. So I'll now join this end or this point O to the end of vector F2. Then I have to measure the length of the line. The length of this line gives the magnitude of the resultant of the two vectors F1 and F2. So I want to measure it now and record it in centimeters. So it's giving me about 7 centimeters. So for my measurement, R is 7 cm. Now that's not my final answer. R is a resultant vector or resultant force. It must be given or expressed in Newton. Now I'll come back to my scale. I use a scale of 1 cm to 10 Newton. So if 1 cm represents 10 Newton, therefore 7 cm will be what? 7 times 10, which is roughly 70 Newton. This is what I got when I use the formula method. So this is one way of finding the resultant of two vectors by triangle method, and that is using scale drawing. So to find the resultant, or the direction rather, alpha of the resultant vector. It is this angle. I can quickly measure that using my protractor. That you know how to measure now. So you keep it like this. This is 10. This is 20. This is about 23. So my alpha gives me about 23 degrees roughly, which is similar to the one we got 22. The one I solved with calculation method, look at that, I got 21.7, which is roughly 22. This one is giving about 22 or 23, approximately 23 degrees. So that is the direction of R. So which means the single force that is actually pulling this box or this load in this direction is a vector of 70 Newton acting direction 20 degrees to the 15 Newton vector. So because that is angle between the vector line and the 50 Newton force.